of Eastman Chemical Company, also head of the Eastman Foundation. It's my great pleasure to be here. I appreciate the invitation from the Consortium on Ocean Leadership. And so the way I think this panel should go, and it's really, you're not here for me, but to give you a brief introduction, and then we'll go ahead and after that and invite up our esteemed panel. So chances are when you flip through the program, when it came, if you didn't, that's fine too. But when you flip to my page, it might have jumped out at you to say, why in the world is, well, first, who is Eastman Chemical Company? And secondly, why are they in the Consortium of Ocean Leadership? And I appreciate that unstated question because it allows me to explain it. I get it a lot. I usually get it twofold. The first question I get, though, because I actually speak quite frequently, believe it or not, on ocean topics, the first question I get is, now what's the importance of the ocean? And then I spend 5 to 10 minutes trying to orient the audience is, well, other than everything in your life is affected by the ocean, I guess as long as you're not living on planet Earth, it's not that important, actually. Fortunately, this audience doesn't need that. But the second piece of it is, why does Eastman care about the ocean? Why does this Fortune 300 company that's headquartered in the mountains care about the ocean? And when I get that question, I say, you point to a place on the globe where the ocean doesn't matter, and then we can probably have this discussion. Eastman's an advanced materials company. We make materials that are in every one of your lives. If you own a car, if you have a house, if you have a TV, if you have a smartphone, if you have clothes, if you use, the list could go on. But when you look at what Admiral White showed about that triangle of energy and food and water, and ask the question, how do we improve that equation? Increasingly, one of the things that needs to be brought to bear is material science. And I'll just pick on something easy like an automobile. As you know, increasingly energy efficiency standards are requiring all vehicles to get better mileage. But how do you do that? Well, one way is to lightweight a car. Well, here's a way not to lightweight a car. Don't take weight from the bottom of the car, because then they flip over really easily. And when you hire a car, that's not what you're looking for. So you have to lightweight the top part of a car. How do you do that? Well, the heaviest part of the top half of the car is the glass. Well, how do you lightweight glass? You make it thinner. Anyone happy about that? Well, it depends on how you make it thinner. If you take one of the Eastman materials, which is a film that goes in between two plates of glass, and it enables you to make a lighter glass pane, and also it enables you to have a quieter cabin. So when you use your hands-free device and drive, that works better too. And in fact, one of our companies invented safety glass, and that's exactly what safety glass is. It's a layer of film in between two plates of glass. In the next generation car, if you don't have it already, you'll have a heads-up display in the windshield. That will be Eastman technology, not the projector, but the actual film that changes the way photons work in a film in between two plates of glass, so that glass is designed to be dimensionally stable when you drive, optically efficient, so you can see through it, but in the unfortunate event of an accident, helps prevent you from going through the windshield. There's a lot of material science that goes into that. And when you think about things that are facing our planet, tuning molecules to do a better job of why we hire molecules is one of the ways we're going to make this work. Imagine if you had a 100-acre greenhouse, okay, that inside were hydroponics, that high efficiency, growing, say, tomatoes. We know that with hydroponics, you can, the average acreage yield is about 20 to 25x what a normal production is. But imagine that you didn't waste all the light, because not all the light is needed to grow the tomatoes. What if you filtered the light so the part of the light that was necessary to grow the tomatoes grew the tomatoes, and the rest were converted into solar energy? All of a sudden that greenhouse takes on a different dimension and a different footprint. Well, that's one of the things we're working on. I could go on about the things we're working on. I'll leave you with one or two other things. You know, we use 1% of energy in the United States today to dry clothes. Think about that. Now, when I grew up, and I'm dating myself, I get it. When I grew up, we dried clothes the old-fashioned way, you know, solar power, which was a little tough in the wintertime, but that's the way we did it. Now we use it, we dry clothes differently. Well, what if you made a material that just dried faster, dry twice as fast. It's another way you could save energy at the molecular level. And so when you think about why is a materials company interested in the ocean? Because we care about the planet. We have an agriculture business, a crop protection business, but beyond that, we're looking for areas of what we call unmet market needs, of where can we get an insight and then translate it into a solution. And so one of the places we've played is working more closely with the Woods Hole Oceanographic Institution. When you look at some of the challenges that Woods Hole has of how do you deliver science with less money, I mean, how many, I won't ask for a show of hands because it would just depress me, of how many of you are trying to deliver the same or better science with less money? Well, one of the ways you do that is look at where the materials are spent. If you look at $1 to $3 million spent on a Met buoy, what if you could, through different materials, make that 90% cheaper? And so Eastman likes to play in the place of how do we, what would happen if you married a project with a company with a multi-billion-dollar materials application laboratory with a world-class not-for-profit organization that needed different materials? What could we do? And so those are some of the things that we're kicking around with what we can do and do differently with the Woods Hole Oceanographic Institution. In addition, that naturally led us to the Consortium Ocean Leadership. It also naturally led us to be a big sponsor of the National Ocean Sciences Bowl. I was pleased to announce the first NOSB team from Eastern Tennessee. Dobbins Bennett High School was at the Blue Heron Bowl after this team of all girls with 2 whole months of practice finished 5th place, and the top 4 had been at nationals in the past. So that's the place that we like to play. Education, awareness, technological development, and bringing materials applications to a world that increasingly needs those applications. So that's what I'm doing here today, but that's also not why you came here. So a brief introduction, and again, in the interest of time, I'm going to be brief in the introduction. You have Representative McGovern and Representative Young's bios. I'm just going to kind of short circuit the process. If we could pick 2 people on this panel, and if we could have one who's a leader in the ocean, the caucus in the ocean, and one leader in hunger, and have them on the same panel and have a dialogue about what's happening in Congress and what can we do in those 2 spaces, hunger and ocean, I think that would be an amazing panel. That's what we've managed to do today. We've managed to have 2 people who are not just lawmakers, but are leaders. Leaders in a space with long history and passion and vision to understand what's facing our planet, what do we need to do today in order to be prepared for tomorrow. Because let's face it, if we mess this up, it's our posterity that pays the price. We'll pay some price, but the people who aren't in the room are going to pay the larger price. So with that, probably a brief introduction, let me invite to the stage, if I can, our distinguished panelists.